Before we start learning about systems of linear equations, let's review the basics. We'll be working with points and we'll be working with linear equations. Let's review what a point is. A point occupies a spot, and in math, that spot appears on a graph. A graph has an x-axis, which is horizontal, and a y-axis, which is vertical. Each ordered pair has an x value and a y value. 2, 3 can be described as where that spot is from the origin. From the origin, we go 2 to the right for the x value and 3 up, 1, 2, 3. For the red point, we would go left 2, 1, 2, and up 4, 1, 2, 3, 4. The gray one, we'd start at the origin and go left 1 and down 4, 1, 2, 3, 4. And the blue point, start at the origin, right 3 and down 2. The green point is 2, 3 in the first quadrant. The red point is -2, 4 in the second quadrant. The gray point is -1, -4 in the third quadrant. And the blue point is 3, -2 in the fourth quadrant. We can also write the 4 points or spots in a table of values. 2, 3, -2, 4, -1, -4, and 3, -2. These spots are random. There's no particular pattern. They're just spots on the graph. There's no length, width, or height. There's no dimension. If we choose 2 points, -1, -4, and 3, -2, 2 points can join to form a line, and that line has a rate of change or a slope. A line could be horizontal and only hit the y-axis. This line's slope would be 0. Or a line could be vertical and only hit the x-axis. This line's slope is undefined. A line is made up of infinitely many points where its steepness depends on the vertical change and the horizontal change. We can use words to describe the slope of a line. It could be positive and pretty steep. It could be positive and not so steep. It could be negative and very steep, or negative and not so steep. The change in y over change in x is constant, and it's called a rate of change or a slope. Using any 2 points on the line, we can calculate the slope, even without seeing a visual of that line. The formula we use is slope is equal to y2 minus y1 divided by x2 minus x1. A line could sit on the x-axis, and we'd call that line y is equal to 0. Or a line could sit on the y-axis, and we would call that line x is equal to 0. A line could hit different spots on a graph. -6, 0 and 0, 2 form a line that hits the x-axis here at -6 and the y-axis here at +2. We can use equations to describe lines. When equations are solved for y, we can see the slope and we can see the y-intercept. Slope here is 2/5, which means a rise up 2 over run of a 5. And the y-intercept is -2, which means the point that hits the y-axis is 0, -2. Using Desmos, we can see this equation is graphed here in green, where the y-intercept is -2 and the slope is rise up 2, run over 5. From this equation, we can see the slope as well. The m value is -2, and a specific point on the line would be -5, -3 from these two values here, comparing with the point slope equation. And there's the point -5, -3 in the third equation, with the slope being -2 over 1, -2 down 2 over 1, down 2 over 1. The middle equation's a little tricky to read off the slope or the y-intercept, but we can easily graph this using x and y intercepts and be able to look at the line that way. For x-intercept, we set the y value equal to 0 in the equation. 2x plus 3 bracket 0 equals 12. We have 2x is equal to 12. Divide by 2, divide by 2, and x is equal to 6. We have a point 6, 0, and for the y-intercept, set x equal to 0 in that equation. 2 bracket 0 plus 3y is equal to 12, and that makes a 0, so divide by 3 both sides. Y is equal to 4. The point is 0, 4, and we've got 1 point, another point, and we can plot those points and see what the line looks like. The x-intercept is 6, 0, and the y-intercept is 0, 4. We could also decide if a given point is on a line, and we can do this two ways. We can either use Desmos, -1, 4 is the point, and 2x plus 3y equals 12 is the line, and you can see that point is not on the line. Or we could use algebra. The x value is -1 and the y value is 4. We're checking to see if that point satisfies the equation. 2 bracket -1 plus 3 bracket 4, does that equal 12? -2 plus 12, does that equal 12? We have 10 does not equal 12. Therefore, -1, 4 is not on the line. We can describe two lines on a graph. We can describe two equations right here being the same line. We could also have y is equal to 4 or a horizontal line compared with the purple line, and we see that those two intersect. We could look at a vertical line and see that there's an intersection point. We could also see an intersection where the intersection forms a 90-degree angle. We could also make up any y-intercept as long as we have the same slope, -2/3 over here and -2/3 over here. We would have two lines that never intersect. They're parallel. Even if you think the lines are looking to be parallel, if the slopes are not equal, -2/3, -7/10, those lines will intersect eventually. And here we can see that. And this little discussion brings us to systems of linear equations. What does it mean to solve a system of linear equations? It means, can you find that exact point where the two lines intersect? Is there a point where that happens? In other words, is there a solution, or are there infinitely many points where that happens? Is it the same line? Or do those two lines or equations never meet? That would mean there's no solution to the two equations.